Okay, so good evening. Good evening. As I said, we'll be taking some wire questions today, and then this is NECO. This is NECO that was written, I think, yesterday. Yes, yesterday. This is 2021. Yes. So I will take question 1 and question 2 because of time. 1 and 2 is what I will take today because of time. Okay, so the first question here had to do with logarithm. I call it logarithm. And then it says, without using mathematical table, find the value of that log 6 to base 10 plus log 45 to base 10 minus log 27 to base 10 without using mathematical tables. That's without using 4-figure tables. So find the log of that. If you see a math is like in this form, you apply what you call the theory of logarithms. The theory of logarithms is what you use here, not tables, not 4-figure tables. You use the theory of logarithms. Like what I did here now. In this case, what I did here was this. Now, I had log 6 to base 10 plus log 45 to base 10 minus log 27 to base 10, and then I applied BODMAS, the law of BODMAS, where B stands for brackets, as you have here, O stands for off, D stands for division, M stands for multiplication, A stands for addition, and D stands for subtraction. So now, addition comes before subtraction in that sequence. So I will bracket the parts that has plus, and then I will deal with it first. And then what I get, I can now subtract it from what is outside the brackets, as I did in this part here. Let me get my pencil so we can follow up well. Okay, that's what I did at this point here. I have to bracket these parts here so I can now evaluate this first, what I get minus that. Now, from my theory of logarithms, I have that if you have logarithm in the same base, say A, like what I did here now, logarithm in the same base, say A, log m base A plus log n base A will be equal to log m times n in base A. That's the law of logarithm. So I've dealt with this law now, and then we also have that log m to base A subtract log n to base A will be log m divided by n to base A. So these are the two laws we'll be applying in this very question. So now, applying those two laws now, we are going to evaluate the addition part first, since plus come before subtraction. So log 6 times 45 to base 10 minus log 27, which we have here. What you have here also, log 27 to base 10. Log 6 times 45 to base 10 minus log 27 to base 10. So if I should evaluate this now, I'll have that 6 times 45 will give me 70. So log 6 times 45 would give me 70 So log 70 to base 10 minus log 27 to base 10. And then from the second law of log that we have here, which I wrote up here, this very law here that I'm pointing now, this very law, in that law we have that log m base a minus log n base a is equal to log m over n base a. So let me get my pencil again. So at that point, I will now do this 270 divided by 27 to base 10. That's what I had at this point here. Is that okay now? So but 270 divided by 27 is equal to 10. So we have log 10 base 10. And in the law of logarithm, once the base is equal to the number, say log a base a is always equal to 1. So log 10 base 10 is equal to 1. So the first question is done. Answer is 1. Question 2, we have solve 8 to the power x equal 32. 8 to the power x equal 32. Now, to solve something like this, you express the both of them in a base of 2. Like 2 to the power of on that number, that's 2 to the power. So I see that but 8 is equal to 2 raised to the power of 3. That's 2 cube. How did I get that? Because 2 cube means 2 times 2 times 2. So 2 times 2 times 2 will always give me 8. Will always give me 8. And then because 2 times 2 is 4 and 4 times 2 is 8. Now 32 is equal to 2 raised to the power of 5, because 2 times 2 times 2 times 2 times 2 is equal to 32. When you do that with your calculator, two times 2 times 2 times 2 times 2 is 32. So I can express 8 by saying 2 to the power of 3 and 32 by saying 2 to the power of 5. Now put that in the equation. That's replace 8 with 2 raised to the power of 3, and then replace 32 with 2 to the power of 5. When I do that, I'll have this. I didn't mean to cancel it. I did not mean to cancel it. Eraser. I will have, what am I drawing? I will have this. That's perfect now. So at this point, we have the same base figure now, 2 and 2. In this case, I can now equate the powers. If I equate the power, it's like me saying cancel this 2 and cancel this 2, something of that nature. And then I'm left with the power, which is 3x equal to 5. And then at this point, I will now divide both sides by 3 to clear off 3. Let x be alone. When I do that now, this 3 will cancel this 3 here. I mean to say this 3 will cancel this 3, and then x will be equal to 5 over 3. 5 over 3. That is the answer. 5 over 3 is the answer. So I could also convert this to mixed number. If I take this to mixed number, I'm going to have one whole number 2 over 3. It's also a valid answer. Question 2C. Question 2C. Question 2C. Question 2C says, or question 1C rather, 81 raised to the power of it's not that clear, power of 1 over 6 divided by 27 to the power of minus 1 over 9. Solving that, I can express them both as a base of 3. 81 is equal to 3 to the power of 4, and then 27 is equal to 3 to the power of 3, which we all know. 3 is the power of 4. It's like saying 3 times 3 times 3 times 3. This point 3 raised to the power of 4 is always 81, and then 3 to the power of 3 is always 27. Here we are. So replace 81 with 3 to the power of 4, and then 27 to the power of 3. When I do that, I'm going to have this. I put it in brackets. I just replaced 81 with this. So I had this here. Then this is still what we have here. Then replace 27 with this. And then this is what we have here. So that means 3 to the power of 4 times 1 over 6 over 3 to the power of, okay, yeah, that's it, because the bracket sign there is like saying times, so I'm multiplying the powers in this case. Well, if I should solve this now, 4, this 4 here, 2 can divide this. If 2 goes here, if 2 goes in this 2, in this 4 here, if 2 goes into 4 here, I will have 2. I'm going to have 2, and if 2 go into 6 here, I'm going to have 3. That's how this came about. And then the next part now, 3 can go into this 3 one time, and that 3 goes here 3 times. So we have, then times this now, give you minus 1 over 3. There's a minus sign here, don't forget. Minus sign here. So 3 here, 3 into this 3 up here 1, this 9 here 3. Okay, so we have this now from there. From that point now, we can now solve this in indices formats from what we know, because the law says that a to the power of m, I'm getting this my drawing well, a to the power of m over a to the power of n is equal to a to the power of m minus n. So apply that law here, it will be 3 to the power of 2 over 3 minus 1 over 3. Of course, when Minus times minus, we always have plus. As I sign change to plus in this part here. Then we have 2 over 3 plus 1 over 3. I should evaluate this stuff that is here now, this very part here. I'll have 3 to the power of I would say is 3. 3 into 3 we have 1. 1 times 2 we have 2. 3 into 3 we have 1. 1 times 1 we have 1 times 1 we have 1. That becomes 3 to the power of 3 over 3 equal to 3 to the power of 1 equal to 3. So I have space equal to 3. Okay. The next one is question 2. Question 2 has to do with gradient of lines. A straight line passed through the points A 3, 0 and B 2, minus 1. So find the line gradient and the line's equation. To find the line's gradients, which we have here, we go with the formula. It's also called M. You can say the gradient is equal to, so M is equal to, it's like you see finding M is equal to that. M is equal to y2 minus y1 over x2 minus x1. So from what we have in our question here, y1 or x1, that x1 is equal to 3 and x2 is equal to 0. This x1, this x2. We have that y1 is equal to 2 and y2 is equal to minus 1. In the next class, I'm going to use something to, I'll create a space for working. I didn't make a space for that in this one. It didn't occur to me. So next time I'll create a blank page where I could also write some stuff. Okay. When I put in those figures now, I have this. Minus y2 is minus 1. Minus y1 is 0 over x2 is 2 minus x1 is 3. So minus 1 minus 0 is equal to minus 1 over m2 minus 3 is equal to minus 1. And then minus cancel minus, we have 1 left. So the slope there is equal to 1. To find the line equation, I can use a simple method to evaluate that, which will give me more stress. I'll just pick any points on the line. In my example now, I picked point A, which is 3, 0. You can pick point B. You pick point A, you make X. This will be the X, this will be the Y. Then you apply the formula. But don't forget that your slope is still equal to 1, which we found here. The slope is still equal to 1. That's the slope. The M, the gradient, is equal to 1. So when X is equal to 3, Y equal to 0, M equal to 1. Applying the formula that says Y equal to MX plus C. That's how to find the line equation. You apply the formula Y equal MX plus C. Your aim at this point is to find C, the constant. So apply your figures there. Y as 0, X or M as 1, X as 3, and plus C, which is not known yet. And finding C, we have that 0 is equal to 1 times 3 is always 3. 3 3 plus C. Quite like terms, however, C is equal to this 3 becomes minus. So C is equal to minus 3. So putting my value of C in the equation y equal mx plus C, where m is equal to 1 and C is equal to minus 3. I'll have y equal to, in this case, don't put x and y. So y equal to 1 times, that one is the m, 1 times x plus minus 3, which is equal to minus 3. So y is equal to x minus 3, and that's the line equation. Number 2b, which I think is the last question here. Number 2b have to do with a shape. It says given ABCD as a parallelogram where line AD is 8 cm and then line AB is 6 cm. I drew that line AD 8 cm, line AB 6 cm. And then the angle of the triangle ABC is 60 degrees. Angle of triangle. Okay, the angle. Okay, angle ABC rather. Angle ABC is 60 degrees. Then we're told to calculate to 3SF the area of triangle ABC and the area of the parallelogram ABCD. Now, from that diagram, now to find the angle, when you translate this question into diagram, you have what I have there. To find the area of triangle ABC, this is triangle ABC. I'll draw a line from this point to this point. It can appear to be a triangle. Oh, the line is not straight. From here to here. It's better off now. So, area of this triangle. Because that can be found using the formula that says that the formula half line AB times line BC times sine of the angle B. So I can say half A B sine B. Half AB sine B. So I'm saying this way. Half A, that's this length here, times B, that's this part of it here. Half AB, BC, then sine B, that's this angle here. Applying all of that now, it's going to be half AB is 6, as half times 6 times BC is 8, half times 6 times 8 times sine B, that's sine 60, and then half times 6 times 8, half times 6 is 3, so 3 times 8 is 24, so I have 24 times sine 60 is 0.8660 to 4 figures, 0.8660. So I put that here, and then 24 times 0.8660, 24 times 0.8660, I get 20.784, approximately 20.8 cm square. And then the area of the parallelogram will be simply, this is one half of a triangle, and then this is the second half of a triangle. So area of one triangle plus the other triangle, or area of one triangle times 2 will give me the area of this parallelogram. So that will be 2 times area of triangle ABC, which is 2 times 20.08. Times 20.08, that's, hope you're following, that's 40.16. So 2 times 20.8, rather 2 times 20.8, that's 41.6 cm square, which I had here. Or I just do it the normal way by saying line AB times line BC times sine theta, and line AB times line BC times sine theta, or times sine B in this case. That becomes line AB, which is 6 times line BC, which it was 6 times 8 times sine 60. 6 times 8, let us do it at once. 6 times 8 times sine 60 will give me 41.59, approximately 41.6 cm square as we had before. So with this, I've come to the end of this class for today. Hope to see you next time. Don't forget to send your comments and your questions. Thank you.